Okay, so today I am gonna help you solve a 4x4. First of all, this one is actually more difficult than the 5x5 just because it has no designated center. Because like there's no actual center pieces except for these, but they'll get scrambled around and they won't stay in the same thing. So pretty much this one is more difficult than the 5x5. But if we just real quickly mix it up, yeah. So again, you do not have to mix it up as I do. You don't have to follow me. And okay, so once you have it mixed up, the first step is to create bars. So like if you see this white one right here, you'll bring in this white one right here, you'll bring it up and you'll create a bar. But then if you look for like this one right here, in this one you can move that like that and you'll have another bar. But as you can see, it messed up right there. So if you real quickly turn this, you can actually get this one up here. But then you can turn that, and you can get this one up here. So if you do that, then you'll get the white side. But then I usually go for the yellow side next. So in order to not mix this side up, you see how we have that yellow one right there? We'll move this one so that the yellow one can move up like this. But after we move that up, the white side will be there. So we'll move the yellow side so that it's not in line with the white side, and we'll move that back. So then that will be fixed and we'll have a bar right there. And now we'll actually create a bar so that we'll have the yellow, and then yellow, we'll move that like that so that there's a bar. But then if you notice this, we can no longer put this back without messing up the yellow center. So what we gotta do, we actually gotta put the yellow center in line with the two bars in line with each other. Then you're gonna move this, so you're gonna move this one out of the way and exchange it with that one. Then you're gonna move the top one twice. Then you're gonna exchange it, and now both of the centers are solved. And now let's go for green because we already have a bar. It's either actually let's see. Okay, yes, we're gonna go for green. So pretty much what you first want to do is you first want to pretty much get as many green or whatever color you're doing onto one side. But then you're going to look right here and you want to get that green right there so that if you were to move this like right there, it would make a bar. And then you move it like that and then you move it back. So you have the green. But then you want to create whatever is left to the orange or green. So whatever's left to the whatever on any side, which this one we're unlucky because these orange need to be on the opposite side. And also if you do not get these centers in the correct places, you'll be unsolvable. But pretty much we need to get all these over here. So what we're gonna do is we're actually gonna make this so that if we are to move this over, it makes it like that. But then this green side is mixed up. So move that down so that we can move this back like that. And now we have that bar. But we also have that center resolved and we have this bar. But then we actually have a bar right here. And we need to get right here. So we're gonna replace it, turn that twice, then do that. And now both of those are solved. Now we just have these last two, which we are actually unlucky because red needs to go here, but we only have one red, and blue needs to go here, but we only have one blue. So what we're gonna do is we're gonna also remember for a color coordination, if you have white on the bottom, it should, in a circle, it should go orange, blue, red, green. Okay. But anyways, if we look right here, we'll put that red right there. We'll turn it so that there's only one red. We'll make it go right there. So it makes a bar. We'll turn it out of the way so that we can restore these two centers. We'll put it like that. Now we have to put these two bars next to each other. we'll move that one up to replace it, we'll move that twice, then we'll put it back. And now we should successfully have all the bars put together. And after we do that, our next step would be to solve the edges. So if I look for like, for example, blue and white, if we need to get, find a edge piece you want to solve. Find the other one, which would be mine right here. You'll move it so that it's diagonal. But then you'll move the top half over so that makes up the two. Then you'll move it up, move one, and move a unsolved one in, and then move the centers back to normal, and that should stay like that. And then if we repeat this step a few times, so actually, okay, this is a good example. So if we have two across from each other, you can do these simple moves where you go up, top, back, then side, side, and it will now be diagonal from each other. And you'll do what I just said, and you'll move the top, move that up, replace it, and then move that back. And then you will then do the same, but if we have two that are across from each other, you'll just do those simple moves again. But then we'll do this. But okay, so here's another example. You can always also move the bottom so that aligns, but then move this side. You do not always have to do the top. Okay, and if we continue with this step multiple times, which, let's see, what would be a good one? It would be this one. So again, they're across from each other, so we'll do these simple moves. Again, there are actually a few moves there is actually an algorithm to flip it in place, but I don't see it as good as what I do. So, yeah, but then you'll just keep repeating this step where you solve the edge, then you'll replace it. But if we have these two right here, okay, so sometimes if there is only one on the top, but it follows your half move, you pretty much only turn that one right there, and then you'll replace it, and then you'll move that back. So it doesn't really matter how you turn that. It could only be this side instead of turning the whole top. But then if we go ahead and find like this, let's see, okay, like that. Again, they are across from each other. And now we'll do this. So remember, they always have to be diagonal. They can never be across from each other, or else it will just not work. But then, what we have to do, okay, so again, like I said, just keep continuing with this one step, and I'm just gonna real quickly finish it. So it'll get easier, of course, the fewer you have, the fewer edges you have to solve. And let's see, I have 1, 2, 3, possibly more left. But so let's see, if I go ahead and do this one simple thing again, you'll see this one is the unsolved one, so I'll move that up, but then I'll real quickly solve that, and then wait, hang on, I gotta move that back, and I actually know it was in the correct spot, never mind. But if they are like over here, you'll just move the top twice to get it down there. And I successfully solved it, but of course there will be one algorithm where you don't solve it. Okay, so, and then if you did only have two sides left and you have nowhere else to replace it on top or on bottom or on any other way, and you only have two edges left, this is the algorithm you have to do. So first, you have to get the two things across from each other. Instead of diagonal like this, you don't want to have them diagonal, you want to have them across. And once you have them across, what you're gonna do is you're actually gonna move the middle or the top half so that it replaces it, so that that other one will be over here. And then what you're gonna do is you're gonna do this algorithm where you go up, front, top, down, front, and then you'll move it back into place, and that should be solved. Okay, now if we go ahead and, okay, so the next step would be to solve it like a 3x3, unless we get a parity, which will, okay, so the meaning of a parity, if we do get one, is a parity pretty much changes. So you'll be doing it, okay, so there's a 3x3 parity, which if we're solving it like a 3x3, the parity will just change the way of solving it, and it adds a second way of solving it, which it just pretty much changes how you should solve it. Okay, but our first part is to make the daisy just like a 3x3, where we put all the white edges around the yellow center. But if you are having trouble with this, do not ever turn it like this in the middle, only ever turn it like this. But if you, okay, so one step, always, so these two are in the edge, okay? So it's kind of like a 3x3, except it's grown, it's like expanded. So these will be edges, and that will be a center. Act as if it's a 3x3, where edge, center, edge, edge, center, edge, corner, center, corner, corner, center, corner, corner. So if you think like that, and you already know how to solve a 3x3, it should be easy enough until you get to a parity. But if we just real quickly solve it, also, if you do not know how to solve a 3x3, I would recommend learning how, or going to another one of my videos to learn how, because I have actually taught it 2 ways, but I'm currently using the beginner method to solve this. If you do use the CFOP method, you can actually skip the second 3x3 parity, which, yeah, but the first 3x3 parity is actually unskippable. But anyways, if we continue with solving it like a 3x3, let me just speed through it. Obviously, you can solve it as fast, 3x3 as fast as you want for this part. So pretty much, I will not be talking much about this part, just because if you're solving a 4x4, you probably know how to solve a 3x3, but if you don't, go check out another one of my videos. I will link it in the description. But if we just real quickly do this, solve 3x3. As you can see, I'm also not that fast with the 3x3, or at least the 4x4 acting like a 3x3. But yeah. So let's see. So you have all that. Okay. And now if we keep solving like a 3x3, so we got the parity. So the parity is where pretty much the yellow cross like this, you only have 3 parts, and this does not happen on a regular 3x3 unless you like flip an edge or something by taking it apart. But pretty much this is like kind of like a T if you look at it like this, except never count the corners. But yeah, it's pretty much missing part of its plus. But if you have it like this, so that the empty part is facing towards you, and you do this algorithm where you pretty much will go up, top twice, whole thing, up, top twice, whole up, top twice, down, top twice, left side down, top twice, down, top twice, up, top twice, down, top twice, down. And that will pretty much make it so we have a full cross right here. But then the next step is where we just like find these two, kind of like a 3x3, we'll put it in the back. Then we do this one algorithm. Of course, again, if you're solving a 4x4 and you're trying to learn how, you should know how to solve a 3x3. I just like emphasizing that just because, yeah, it just makes sense to know how to solve a 3x3 first. But then we'll look for any corners that are solved. If not, we'll do this algorithm. This cube is not that good anyways. And so pretty much, if we go ahead and do this, we'll get this parity where we have two corners that are not solved. But if we don't have any, you can also do this parity. But two corners that are solved and two corners that aren't. This does not happen on a regular 3x3 again. And so the first thing we are gonna do is where we do this, we'll pick it up, and we'll do this algorithm where we go middle row twice, then top twice, middle row twice, then two top rows, middle row twice, and then the middle of the top. And then that will give us this, which we then have to redo the step we just did, because it will set you back just a bit. But just keep going, and then we should reach where we just were, and then we continue, and then we should get it to where we have all four corners solvable, and we'll turn it upside down. We'll just keep doing our algorithm, and then after this video, you should know how to solve a 4x4. But again, lots of the steps in this video are actually 3x3. So I will link the 3x3 video in the description, and that's all.